Welcome to day 37, Debugging Techniques in Python. In this session, we will explore essential debugging tools and strategies that will help you identify and resolve issues in your Python code effectively. First, let's understand the types of errors you might encounter in Python. There are three main categories. Syntax errors. These occur when there's an issue with the code structure, like missing parentheses or incorrect indentation. Runtime errors. These happen during execution, such as trying to divide by zero or accessing an invalid index. Logic errors. These are tricky because the program runs but produces incorrect results. These errors often require deeper investigation. Effective debugging starts with understanding how to troubleshoot common issues. You can use print statements to track variable values and the flow of your program. Define the problem area by narrowing down the issue to a specific part of the code, commenting out sections if needed. Simplify the code to isolate the error. And finally, read traceable read tracebacks carefully. When an error occurs, Python provides a traceback with information about where the error happened, which helps you locate the issue. Let's dive into using PDB, Python's built-in debugger. You can set breakpoints in your code using the import pdb.setTrace statement. This will pause the program at that point, allowing you to interactively inspect variables and step through the code to track down bugs. When you are using PDB, there are several commands you can use to navigate through your code. N stands for N next, execute the next line within the current function. S step into a function called to debug it. C continue, resume the program until the next breakpoint. P expression, print the value of an expression. Q quit, exit the debugger when you are done. Here's an example of using PDB in a function that divides two numbers. Notice the pdb.traceback call. When the program reaches this point, it will pause and you can inspect the variables a and b and step through the code line by line. Moving beyond the basics, you can also use IDE debuggers for a more visual debugging experience. Popular IDEs like PyCharm and VS Code allow you to set breakpoints, step through your code, and inspect variables with ease. Another valuable tool is logging. Using Python's logging module, you can keep track of program behavior over time, making it easier to identify and debug issues later. Here's an example of how to use the logging module. Instead of using print statements, logging provides a more flexible solution. With logging, you can log messages of different severity levels such as debug, info, warning, error, and critical. Unit testing is another powerful technique for debugging. By writing tests for individual functions, you can catch bugs early, ensuring code works as expected. Unit tests also help isolate errors and they ensure that future changes to the code do not introduce new bugs. Now it's time to practice. Here are three exercises to help you refine your debugging skills. Write a division function that handles division by zero and use PDB to debug the exception. Create a script with a logic error and use PDB to find and fix it. Implement logging in a small banking system program. Introduce an error and debug it using logs and breakpoints. To summarize, debugging is an essential skill for any developer. Use print statements, PDB, and logging to troubleshoot effectively. Leverage advanced tools like IDE debuggers for a more visual experience. And remember, unit testing is a great way to catch bugs early. By practicing these techniques, you will become a more efficient and confident debugger.